This will be the Chapter 4 notes for first year chemistry, and the name of the chapter is Problem Solving in Chemistry, and the type of problems that we're going to be solving in this particular chapter are called conversion problems. They're also known as dimensional analysis problems. Dimensional analysis is a fancy way of saying that you're going to be tracking the units that you're changing from one unit to another. So in our example problem we have how many seconds are there in 3 weeks. The dimension is the number of weeks, and we're going to analyze that unit and we're going to change it eventually into the word seconds, so we can change weeks into seconds. So this is a method of keeping track of the units. Now, what is a conversion factor? Well, that's simply a ratio of units that are equivalent to one another. So some examples would be in 1 minute, that's equivalent to 60 seconds, or you could flip the ratio and make it 60 seconds in 1 minute. The next example would be 7 days per week, or 1 week per 7 days. In the third example, we have 1,000 meters is 1 kilometer, or 1 kilometer is 1,000 meters. Now, these conversion factors that I've just given you 3 examples of need to be set up in such a way that when you multiply them by whatever the given unit is, that given unit cancels out and you're left with the unknown unit. So if I look at how many seconds are in 3 weeks, you would need the word weeks to cancel out and eventually be replaced by the word seconds. Now, there isn't a simple conversion to go from weeks into seconds, but you can go from weeks to days, and then from days to hours, and then from hours to minutes, and then minutes to seconds. So if you're changing, let's say, something from minutes to seconds, you would have to have the unknown unit, which is seconds, on top. So if you're changing from minutes to seconds, you know the number of minutes, but you don't know the number of seconds. So you'd put the unit 60 seconds on top, and then you'd put 1 minute on the bottom of the ratio. So you need to set up the units correctly so that they're going to be canceling out. And we will look at some examples on the next slides. Now, on the second slide, we have 5 steps to follow when you do a dimensional analysis conversion problem. The first step is to identify the given, and this is typically the only number given in the problem, and that's your starting point, so you need to write that number down, and then you put a little times line, which is going to be our conversion factor ratio. Then the second step is that you identify the unknown, so you need to figure out what you're trying to get to. So, for example, when you're going from weeks to seconds, the given is 3 weeks, and the unknown is the number of seconds. Then for step 3, you're going to identify the conversion factors. Sometimes I'll give them to you, sometimes you'll have to know them, like how many days are in a week or how many minutes are in a second. For step 4, you're going to use the conversion factors in such a way to plan a solution. So again, if you're going from weeks to seconds, you just can't do it in one step. You have to plan a solution, go from weeks to something smaller, like the number of hours or number of minutes, and then to number of seconds. So you have to plan a solution. Then in step 5, you're going to set up your conversion factors in such a way that the units cancel out correctly, and then you're going to multiply by all the numbers on top of your ratios, and then you're going to divide by all the numbers that are on the bottom of your ratios. So if you didn't do it correctly, your units are not going to cancel out, and you can clearly see that you've done something wrong. So we're going to look at 3 examples on the next slide. In the first example, we have 3.25 days, and we're going to change them to the number of hours. So you write down the given, you put your times line, we're going to set up our first conversion factor, and there's a simple conversion from the number of days to hours, or from hours to days. In this case, we need the word days on bottom to cancel out, so we're going to put 1 day on the bottom, and you can change it into hours by putting 24 hours on top. Then you can see that the day unit will cancel out, and you'll be left with 78 hours as your final answer. So 3.25 times 24 is 78 hours. In example problem number 2, the given is 504 inches. You put your little times line. The unit that you're going to try to cancel out is inches, and I'm not going to go directly from inches into yards. I'm going to do this in 2 steps. I'm going to go from inches into feet. So we put the units of inches on the bottom and the word feet on top. So you should know that there's 12 inches in 1 foot, but the 12 inches goes on the bottom because you need that to cancel out with the unit that's already in the top position, or in the numerator. So they have to be in the opposite positions in order to cancel out. Once you've canceled out the word inches, you can now worry about changing the word feet into yards. You put another conversion factor in place. The word feet are going to go on the bottom, and yards will be on top, and the conversion from feet to yards is 3 to 1. So the 3 is going to be in the denominator, again, because the unit of feet's in the numerator already, you need it to cancel out. So you put them in the opposite location, you cancel out your units, and then you do the math. You have 504, that's going to be divided by 12, and it's going to be divided by 3, and you get 14 yards. In the last example, we have 2,6,748 seconds. It's 26,748 seconds. That's our given. Write it down. Put your times line. The unit of seconds goes on bottom. We're going to change it to minutes by using the ratio of 1 minute over 60 seconds. The next conversion factor, you know that minute has to go on bottom, so we're going to use 60 minutes in the next ratio, and we're going to convert it to hours, and then those units can successfully cancel out, and then you can change hours into days, and you're going to use that ratio of 24 to 1 again. 24 is on bottom because the unit has to cancel out, and we have days on top. In your calculator, you're going to take the given 26,748 divided by 60 divided by 60 divided by 24, and you're done. That technically has 5 sig figs, as the given has 5 sig figs, and you can move on. The last slide is converting complex units, and that's a measurement with a unit that's in the numerator and a unit that's in the denominator. And we've seen this before in the last chapter when we had density, like 18 grams per milliliter. That's a complex unit because there's a unit on top and bottom. Velocity is also a complex unit like miles per hour or meters per second. To convert a complex unit, you're going to follow exactly the same procedure as before, except you're going to just worry about one word at a time. You're going to do the top unit first, and then you're going to convert the units that are on the bottom. So in the first example, we have the given. It says the speed of sound is about 330 meters per second, so that's the number that we write down first, and we need to convert this to miles per hour. So let's first change meters to miles by multiplying by our ratio that's given. It says 1609 meters, that'll be on bottom, and then we have 1 mile on top. The units of meters cancels out, and you're finished with the word on top. Now you need to focus on changing the word seconds, which is in the denominator, to the word hours. So I know of a conversion factor to do this in one step. It takes 3,600 seconds to get 1 hour, so you can put that ratio as shown, and the units of seconds can cancel out. Notice they're in the opposite location. If it's in the denominator to begin with, your conversion factor must have it in the numerator. We need hours to be in our final answer in the denominator, and that's what happens when you put it in the correct position. So now you have the units of miles on top and hours on bottom. You're going to take 330 multiplied by 3,600, and you can divide by 1609 to get your final answer. 738 miles per hour. That's approximately the speed of sound. For the second example problem, we're going to change the density of water, which is the given unit of 1.0 grams per milliliter, and we're going to change it to pounds per gallon. So let's change the word grams eventually into the word pounds. In order to do this, we need to recognize that 1 kilogram is 2.2 pounds. So we need to change grams to kilograms first, and then we can use the conversion factor that's given. Grams will be on bottom, and you can change it to kilograms by using the factor of 1 over 1,000. The units of grams successfully cancels. Now you can change kilograms to pounds. We put 1 kilogram on bottom and the 2.2 pounds on top, and then the units of kilograms can cancel. And then the last ratio, we're going to change milliliters into liters eventually. It's actually going to take 2 steps, just like the first unit took 2 steps. We need to go from milliliters to liters, then we can go from liters to gallons as the conversion factor is given to us. 3.78 liters is 1 gallon. So we put our times line. We have to have milliliters on top, and we're going to use this ratio of 1,000 to 1. 1,000 milliliters is 1,000 liters, and then again we can successfully cancel out a unit in the numerator and denominator, and then we can use that conversion factor that's given to us. The 3.78 liters has to go on top in order to cancel out the word liters, and we put 1 gallon on bottom, which is where the unit needs to be in our final answer. The unit of liters cancels out, and if you're aware of what you're doing, you can also look for numbers that cancel out, and in this case we have the number 1,000 canceling out on top and bottom, and then it makes the math a lot easier. We just have 2.2 times 3.78, and all the other numbers are 1, so you only have one little multiplication to do, and you get 8.3 pounds per gallon. In our last example, we have not a complex unit but a squared unit. So we're going to try to convert square inches into square meters. And you do this pretty much like you've done the other problems. You write down the given and you look at what unit you're trying to cancel out. And we know that has to be in the denominator. And so we're going to change inches eventually into square meters, but we first have to go from inches to feet and then feet to meters. Now these are squared units, so we can still write down our conversion factor of 12 and 1, but we have to square the whole conversion factor in order for the units to cancel out correctly. So you can use the ratio again of 1 foot on top and then 12 inches on bottom, or 1 foot. 1 foot on top and 12 inches on bottom, but you're going to have to square that conversion factor in order to have the units cancel out correctly. And then in your last ratio, we're going to change feet into meters. So we can put feet on the bottom and then meters on the top, but we have to square everything. So when you're doing this in your calculator, you're going to have to take 33,500 and multiply by 1 squared, and then multiply by 1609 squared, and then divide by 12 squared, and divide by 5280 squared. So everything is squared, the numbers and the units, for them to successfully cancel out. So if you do this right in your calculator, you should get the answer of 21.6 meters that are squared. So that's how you change a squared unit into a squared unit. You'd use the same technique if it was a cubic unit to another cubic unit, except you would have the whole conversion factor cubed in order for the units to cancel out. And again, as a reminder, if the conversion factor is in a parentheses and you've squared it, you square not only the units but also the numbers. So that's a quick review of what we cover in class in Chapter 4.